In the last lesson, we introduced the idea of the unit circle. And so this should already be familiar. If you haven't already watched that lesson, go watch that lesson first because it gives you context for what we're talking about here. And the biggest thing about that was seeing that in the unit circle, it's centered at 0, 0 and has a radius of 1. And that radius of 1 is going to be particularly useful with what we look at today. I'd like to know first, in order to lay a foundation for where we're going, what is the circumference of the unit circle? Well, of course, in order to do this, you have to remember the equation to find the circumference of a circle. Hopefully, you are thinking of C equals 2 pi r, because 2 pi r tells us the overall circumference. If you're thinking pi r squared, you are thinking area there. The fact that there's a squared in it tells you that, yeah, it's probably going to be an area equation, and indeed it is. All right, but this one is circumference, so we're going to be doing 2 pi r. In order to figure that out then, I'm going to be doing 2 times pi, okay, that's just is what it is, times r. Now, what is the radius of this circle? Well, remember, it's a unit circle. It has a radius of 1. So the circumference is going to be 2 pi times 1, which of course means that the circumference then is just going to be 2 pi. Now, remember what that means. When I'm talking circumference, I am talking about the total distance that I would have to travel around the outside of this circle in order to get right back to where I started from. And the cool thing is that if I can find the total circumference of the circle, I can find the arc length of the circle at any given angle, really. We're going to start with 180 degrees. And remember, 0 is straight over here to the right. The total circle would be 360 degrees. So 180 is about half of that. So my 180 is going to be over here straight to the left. So what it's talking about here, when it talks about arc length, is it's saying that if I start at 0 and go around the circle up to 180, how long is that part? How long did we have to travel in order to go around the outside of the circle there for half of the circle in this case? Well, we can actually take the circumference that we know from before, where we knew the total circumference was 2 pi, and the 180 degrees that we're working with, that's going to be how much of the total circle we're actually tracing out here. So if I do 180 divided by 360, that ends up giving me 1/2. I can actually just simplify the fraction in that case, but you could also divide it and get 0.5. And so if I wanted to then know what is the total arc length here, I'll use L for the arc length, then I want to figure out what is 1/2 of the total circumference, which means 1/2 times the circumference of 2 pi. And remember, this is the unit circle, which is why I know the circumference is still 2 pi. I'm not changing the radius. So if I then do that, I end up figuring out that, well, 1/2 times 2 is just 1. And so it would be 1 times pi. Well, of course, I don't really need to write 1 pi, do I? So I can just say then that the L here would equal pi. And so that is the arc length at 180 degrees. Let's do that same idea on a few more practice problems here. In this case, we're going to take a look at the arc length at 90 degrees. First up, let's actually identify where 90 degrees is on our circle. 90 degrees would be up here, just help visualize. And so when we're talking about this arc length, we're talking about this distance around the outside between 0 and 90. That's what it's really asking us to find. Although really you didn't even have to draw it in order to know that, because it's still a unit circle, so I still know the circumference is going to be 2 pi. And I want to know in this case what fraction of the circle is 90 degrees. So I'm going to do 90 over 360, and that'll tell me what fraction of the circle we're dealing with. And again, you can reduce it as a fraction to get 1/4, or you could actually do 90 divided by 360 and get 0.25. And you can use it in either way, either as the fraction or the decimal. So then if I want to figure out this particular arc length, I'm going to do 1/4 times that total circumference of 2 pi. All right, this one maybe not quite as simple to do as the last one. I want to leave it in fraction form. I don't really want to do a decimal at this point. And I know you can use a decimal when doing some of the calculations, but I really would rather leave the answer as a fraction. So let's see here. In order to make that a fraction, let's make the 2 pi also into a fraction. That'll make multiplying the fractions easier. So anytime you want to make something into a fraction, remember you can write it over 1 if it's a whole number like this. So it's going to be 2 pi over 1. And then I can multiply the fractions, because to multiply fractions, I go straight across the top and straight across the bottom. And so that would mean that my arc length here would be 2 pi over 4, which you notice will reduce. I can divide both top and bottom by 2. So that means that my arc length here would equal pi over 2. That is the final answer that I'm looking for here, is that the length is pi over 2. And yes, leaving it as that fraction is going to be important going forward. Now we're going to do another practice problem here. In this case, we're going to be working with 45 degrees. So 45 degrees, that's going to be about halfway to 90. So we're really looking at that arc length, because that would drop us off at about 45 degrees. So again, I know my circumference of the whole circle is 2 pi, and really I just want to figure out what fraction of the whole circle is this. So I'm going to take my 45 degrees over 360, and I want to be able to figure out what fraction of the whole is that. And so, yeah, we can go ahead and still reduce that down, and if I reduce that, it ends up giving me 1/8. All right, so then if I want to know the total arc length, then I'm going to end up doing 1/8 of the circumference, which means 1/8 times 2 pi. And again, I can turn both of those into fractions in order to be able to multiply those fractions straight across the top to get 2 pi and straight across the bottom to get 8. And then last step is just reduce that fraction. 2 pi over 8, I can divide both top and bottom by 2 here, and so I end up getting pi over 4. And so that is my arc length at 45 degrees. By now you're probably getting a pretty good hang of this, so we're going to do this one here in a moment, but it might be a great idea to pause this video here and try doing this one on your own first, and then resuming the video to watch us work it through together. So this time we're looking at 60 degrees, so still starting at 0. I'm going to be going up here to around where 60 degrees is. And you know, I could kind of visualize where that angle is here. So I first want to know what fraction of the whole is 60 degrees. Well, it's 60 over 360. Okay, let's go ahead and reduce that down. That's going to give me 1/6. So then the total arc length here is going to be 1/6 of the total circumference, which is 2 pi. And so again, make them both into a single fraction. So that's going to be 1/6 times 2 pi over 1. And therefore L equals 2 pi over 6, or reduce it, and yes, we do need to reduce it, and so it equals pi over 3 for that arc length. And another one of these practice problems. And by now I think you got the basic idea about how to approach these. But I'm now going to then show you a slightly different way of approaching it in order to be able to come up with that answer basically in one equation. Instead of having to figure out one thing and then plug it into another thing, we can actually set it up as just one equation from the start. And so in order to do that, we can actually use proportions to our advantage. Because remember, we're first figuring out what fraction of the whole is our particular angle. So we're doing this, in this case, 72 over 360. But instead of just figuring out what that number is and then plugging it in, we can actually set up another side to our proportion here. Because the entire circle here was 360 degrees, and the entire circle circumference is 2 pi. And so really I'm just figuring out what portion of that circumference is it. And so we're figuring out what is this unknown. And I'm just going to go ahead and call it x for the moment here. So notice I can now actually just write a single equation in order to be able to figure that out. All right, so knowing that, I can now solve that by cross multiplying. And so I'm going to do 72 times 2 pi. If I do that multiplication, it gives me 144 pi. And then I'm going to end up doing the 360 times x, which gives me 360x. And so if I want to know what x is, I would then divide both sides by 360. And so then I end up getting 144 pi over 360 is my unknown. Now at this point, I can go ahead and reduce my fraction. And so we go ahead and we do reducing. And I'll actually notice that I can divide top and bottom here by 72. And so I end up getting 2 pi over 5. And so in this case, my arc length, which is measuring up here to about 72 degrees, actually up to exactly 72 degrees, is 2 pi over 5 around the outside. And so I was able to do it with just a single equation. And there's pros and cons to both of these approaches. And strictly speaking, you can use either one. But I will tell you that I'm going to use this proportion method going forward a lot more than I would the other one. There's just one little thing about this process that I would actually like to change, and that is the x. The fact that I called it x, I actually want to change that here. Instead of calling my variable x, I'm going to call that variable r. And you might be wondering why. Is it because it's radius? No, it's not radius. Although it is a word that sounds like it, but this is actually what this lesson was really leading up to, is that what we just found by finding the arc length around the outside of the unit circle is that we actually figured out what the radian measure of that angle is. Because we've always measured angles with degrees. And degrees are basically a way of measuring an angle at its center. So this is where we would measure degrees from. But radians are a different way of measuring an angle. Radians are a way of measuring an angle around the outside of the circle that the angle traces out. Specifically, we're working with the unit circle. Another reason why the unit circle is so foundational to some of this work. And so radians are just a different way of measuring an angle. It happens, though, that radians, because they actually mean something directly on the circle, like something actually physical on the circle, the distance around the outside of it, radians end up being used a lot more the further and further you go in your mathematics career and in other applications like science that use this sort of thing. Degrees are going to start disappearing over time in terms of their usefulness, because what does 1 degree really mean? Well, really, it's just an arbitrary choice where we decided to divide the circle up into 360 of them. Why didn't we decide to divide it up into 100 degrees or 120 degrees or 5,000 degrees? It's a fairly arbitrary choice, right? A single degree does not hold any special meaning to us. And that's important to remember, because a lot of times people look at radians and they say, what does a radian mean? Well, a radian, and this is actually drawing in about where 1 radian would be, a radian also has no particular meaning just on its own. So saying 1 radian around the unit circle is not very helpful, and basically you never hear people talk about 1 radian. You might hear people talk about pi radians and 2 pi radians a lot more. Those are going to come up a lot, as you'll see, but that's because, again, radians are that distance around the unit circle, and of course that whole circumference is 2 pi. So when we talk about radians, pi is almost always in the conversation. But this idea of just what's 1 radian, not really a useful idea there. And so now with that idea kind of established, and we're going to keep coming back to it here as we go forward, I want to do one more of those problems where we find the missing arc length. Just this time, I'm actually going to set it up using some of this vocabulary. So first of all, in general, what we want to do is we want to take our number of degrees and put that over 360. And then I'm setting up my proportion again. And so that's going to equal something over the total circle in radians, which is 2 pi. Remember, the total circle in radians is exactly the same as the circumference of the unit circle. But I want to figure out how many radians is it just to get to 270 degrees. So in other words, what's this arc length? just going around here. And so then I'm going to figure out what is r over 2 pi. And I'm using r again because this represents radians. In fact, to give you a general formula here, rather than writing it as 270 over 360, if I just wrote it as d over 360, now all of a sudden it's a general formula. This is actually going to be the general formula that you can use to switch any angle from degrees into radians or also from radians into degrees. Although we're going to save that last one for another day. But back to this particular problem here. And we are trying to figure out what is 270 over 360 going to give us in radians. Well, again, we're going to cross multiply. So I'm going to do 270 times 2 pi. That gives me 540 pi. And then that's going to be equal to, multiply the other direction as well now, so that's going to equal 360 r. And we want to go ahead and get the r by itself here. We're trying to solve for the radian value. So I'm going to divide both sides now by 360. Now, once we do that, we now have 540 pi over 360 equals r. So we basically have our answer. It's just a matter of reducing it. And yes, you do always need to reduce your answers for your radian angle measures. And so I can see right away in reducing this, one of the big clues to always look out for is if they both end in zeros, you know you can divide both top and bottom by 10. If I only do that, this is already looking a lot simpler, right? And I can say, okay, what numbers go into 54 and 36? Well, it looks to me like 9 goes into both of those. So if I divide both of those by 9, that would give me 6/4. So 6 pi over 4. And this is looking pretty good. I mean, but it actually still reduces one step further because I can still divide both top and bottom there by 2. So notice when reducing, yes, you can go ahead and just take it in phases. You don't have to figure out what's the biggest one that goes into both of them right away. And so we end up finding then that our radian value here is 3 pi over 2. And so I've now converted the degrees into radians or found the arc length because that's the exact same idea, that all the radians are is the arc length around the unit circle up to that angle. Now I'm going to break away from the picture here, and we're just going to do some straight conversions from degrees into radians. So here we have two different angle measures, and we're going to be converting both of those into radians. Now the first thing we need is we need to know how to do it, right? And yes, you still could start by separately figuring out like what's 135 over 360 and taking that number and then reducing that fraction, then multiplying that by 2 pi and turning that into a fraction and multiplying it. But it's a lot of separate steps that you have to remember. Whereas if you just remember this one formula, then you're only remembering one thing about it because you already know the process for solving a proportion. So it's only adding one new layer, which usually makes the whole process a lot easier to remember. That's why I like having a single formula here instead of a multi-step process. So I'm going to use that formula. And the D on top stands for the degrees. And in this case, I know what the degrees are. It's 135 degrees. So I'm going to start by writing 135 over the 360 equals, and now I hit R. Do I know what the R is? No, because the R stands for radians. That's what I'm trying to figure out. So I'm going to leave that as R and put that over 2 pi. I now have my equation set up. Now it is a matter of actually just executing the mathematics behind solving the proportion. So we cross multiply. If I do 135 times 2 pi, I end up getting 270 pi, and then that equals 360 r. All right. Still, to get the r by itself, I'm going to divide both sides by 360. So divide by 360, and here we have 270 pi over 360 equals r. And yes, we do need to reduce it here. Obviously, we can divide both top and bottom by 10. And then we can also divide top and bottom by 9. So actually, we could have started by dividing top and bottom by 90 as well, if you wanted to do it that way. Whichever way you do it, whether you do it just by dividing once or you divide and then divide and divide until you can't divide anymore, you should end up with an answer here of 3 pi over 4 equals r. And notice pi is part of our answer. It is almost always part of our answer when we're giving a radian measure. If you get a radian value and you don't have pi in it, you probably just forgot about the pi someplace along the line and are missing it. So make sure to include that. And yes, we do generally leave pi in there. In case you're wondering, couldn't we just calculate that out as a decimal? Yes, you could. And that decimal has real meaning. That gives you the real length around the circle. However, it's an irrational number. It's one of those decimals that goes on forever and never ends and never repeats itself. And because those are a real pain to deal with, we just leave the pi in there. All right, let's go on to our second one. And this is a great opportunity for you to write it down and do it yourself first, like pause the video lesson here, work it, and then come back to it. I suggest you do that now. So let's take a look at how we would go about converting this one into radians. Again, the number that I have here is the degrees. So I'm going to plug it in for d in my equation. So that's going to give me 210 over 360 equals r over 2 pi. Now it's just a matter of solving this for r. And yeah, I've always cross multiplied at this point in all the examples we've done here, but I'm actually going to go one slightly different direction this time. Because sometimes people ask me, well, I think this might be easier. Can I reduce this first before I multiply by the 2 pi? Yes, you can. And so just in case you are one of those types who would rather reduce it at that point and then go on and do the multiplication because the numbers are going to be a little bit smaller, let's see how that would look. So I'm going to start by reducing 210 over 360. Certainly I can divide both top and bottom by 10. And then 21 and 36, 3 goes into both of those. And so if I divide both of those by 3 then, it's like dividing the whole thing by 30 at the start, in case you're curious. That will give me 7 twelfths. And so now I have 7 twelfths equals r over 2 pi. And if this feels way more comfortable to you, yeah, you can feel free to do it that way. And then I cross multiply from here. Yes, you will always have to cross multiply at some point. So I do the 7 times the 2 pi. That gives me 14 pi. And then I multiply the 12 times the r, which gives me 12r. Now I wanted to go ahead and get the r by itself still, so I'm going to divide both sides by 12. And so then that would give me 14 pi over 12 equals r. Looking pretty good. And we did reduce up here, remember, but you'll notice that we still actually have a little bit of reducing here to do at the end. So even if you reduce at the start, you might still have some reducing to do at the end still. So in this case, I can divide both top and bottom by 2. It's an easier simplification at least. And so then that's going to give me 7 pi over 6. And so the radian value here is 7 pi over 6. And that one is done. Having gone through this lesson on radians, it would now be useful to write down a summary of what we've talked about and what we've learned about radians here. And so, first of all, we have our definition of what radians are, where a radian measure is just the length of the arc on the unit circle. And again, it's just on the unit circle. So going back to that same idea. All right, so that means that a full circle, therefore, is 2 pi radians because the circumference of the unit circle is 2 pi. That's why 360 and 2 pi are always on the same level in our little equation down here, because they both represent the total circle. When writing our radian measure, we always want to write it as a reduced fraction, and yes, leave it in terms of pi. We talked about how 1 radian has no special meaning just in itself, so don't try to get hung up on that part. And we learned this formula here that is used to be able to convert between degrees and radians. And so make sure you have that formula down and that you can do this conversion from any angle in degrees into radians going forward.